Hello math learners! In terms of quadratics, we have already discussed quadratic equations as well as quadratic inequalities. Today, we're going to discuss the third and the final aspect about quadratics, and that is all about the basics of quadratic functions. So before anything else, hit that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the most essential learning competency based lesson for quarter 1, week 6 of the grade 9 mathematics, which is all about the basics of quadratic function. Now, as you can see in our whiteboard, we have a lot of terms that you will encounter about this topic. But don't worry, because as we discuss these terms, today, this will become very easy for you. Okay, let us start. Quadratic function is basically a quadratic equation in two variables. Remember that the meaning of quadratic is the second degree, or the highest degree is in the second power, while function is the relationship of two variables. So putting them together, quadratic function is a function in the second degree. Or in a layman's term, it is a quadratic equation in two variables, meaning we will be talking about x and y, or x and the function of x. Not like quadratic equation in our previous videos, we were just talking about x squared, right? And in the quadratic inequalities, we were talking about the inequality symbols. But now, here in quadratic function, it is all about x and y. Okay. Now, knowing that our quadratic function talks about the relationship of x and y, basically, we will gonna use this one. Because this is a Cartesian plane or the rectangular coordinate system, and this represents the relationship of the x and y axis. Okay, now, the quadratic function has two forms. This is known as the general form and the vertex form. If you could still remember in our topic about quadratic equation, the quadratic equation is ax squared plus bx plus c is equal to 0. Now, here in quadratic function, the general form of a quadratic function is ax squared plus bx plus c, but this equal to 0 will become y, or the function of x, giving us a variable of x and a variable of y. And still, a, b, c are real numbers. Easy, right? Okay. Now, what is the other form of a quadratic function? That is the vertex form. The vertex form says that y is equal to a times x minus h squared plus k. In which, since this is vertex form, we are talking about the vertex. And if your quadratic function is in this form, by just looking at it, you can now determine the vertex of the graph of that quadratic function, which will be placed in our Cartesian plane. Easy, right? Okay. So again, this is the general form. Ax squared plus bx plus c is equal to y. And our vertex form, y is equal to a times the quantity x minus h squared plus k, where h and k is the coordinates of your vertex. Okay, now, let us go to parabola. What is a parabola? The parabola is basically the graph of a quadratic function. Now, what does a parabola looks like? If you could still remember your topic in grade 8, we talk about linear equations. And the graph of linear equations is basically a line. It's either vertical, increasing, decreasing, or horizontal. Now, in quadratic functions, parabola is basically two-way. It is upward or downward. What does it look like? It looks like a U or an inverted U. Okay? So, if the parabola opens upward, then this is the graph of a parabola. When it opens downward, this is what the parabola looks like. Okay? So, as you can see, in this given parabola, we have here the turning point. In this parabola, we also have here the turning point. And that is what we call the vertex. Okay? So, the turning point of the parabola is known as the vertex. Okay? So, let's go to the vertex. And the vertex is, again, that is the H and K, which will be taken from our vertex form. Easy, right? Okay. Now, let's go to the next term, that is minimum or maximum point. A parabola can either, meaning it can either be minimum or maximum point. Now, let's go back to this scenario. As you can see here, we have two parabola, right? Okay. One that opens upward and one that opens downward. When the parabola opens upward, you have a minimum point. Meaning, there is a certain point below that is the turning point of that given graph. And that is what we call the minimum point. While if you have a parabola that opens downward, then the turning point of that parabola is what we call the maximum point. Other books use the term minimum point or minima, and other books also use the word maximum point or maxima. Okay? So, talking about vertex, the vertex can be minimum or maximum depending on your parabola, whether it opens upward or downward. Okay, easy, right? Now, let us go to the next. Table of values. What is a table of values? Basically, when you are graphing any kind of function, table of values becomes very handy. Why? Because the table of values will let you give certain coordinates that might be used in plotting your points in the graph. Now, what does a table of values looks like? A table of values has two rows, okay? That is the x and y. And then, it's like a table, okay? And you can use any distinct number or value for your x, and then you solve for your y so that you can have an ordered pair, which is this one will be the unordered pair, this one is another ordered pair, and this one is another ordered pair. Example, if we have 2 for x and then 3 for y, meaning that your ordered pair is located at 2, 3. Okay, so if you have series of coordinates in your table of values, then it would be very easy for you to plot those coordinates in your Cartesian plane, and eventually it will become your graph. Okay, easy, right? Now, let us go to the direction of the graph. Basically, we are already talking about direction of the graph. It opens upward or downward. Remember the relationship of these terms. When it opens upward, it has a minimum point. When it opens downward, it has a maximum point. That point of where the parabola turns is what we call the vertex. Okay. Okay, now let us talk to our third to the last term. This is the axis of symmetry. Now, what is the axis of symmetry? Axis of symmetry is basically the value of your h in your vertex. Now, remember earlier that our vertex is represented by h and k, right? Okay. So, this value is also known as your axis of symmetry. Now, what does this mean? If you have a parabola, and then this is the turning point, right? The axis of symmetry is a line that is parallel to your y-axis. Sometimes it becomes your y-axis, but sometimes it is parallel to your y-axis. But for you not to be confused about this matter, basically the axis of symmetry is a line that cuts your parabola into two equal parts. Meaning, if this is your parabola, a line that cuts the parabola into two equal parts, that is your axis of symmetry. Okay? And for you to get the axis of symmetry, or to locate where the axis of symmetry is found, then you just need to consider the value of your h. Now, for example, let's say the given is in the vertex form, so your h is your axis of symmetry. Now, what if the given is in the general form? Ax squared plus bx plus c is equal to y. Is there a way for you to get the axis of symmetry? Well, there is, because you just need to use a certain formula and you plug it in, you solve it, you simplify it, you will have your axis of symmetry. What is that formula? That is negative b over 2a. So your b here will be the b in your expression, and your value of a here will be the a here. You just simplify this formula, and you will have your axis of symmetry. Easy, right? Now, do not worry about how to solve this kind of matter, because on our next video, we will be talking about solving and transforming different forms of quadratic functions. Okay, now let us go to our x and y intercepts. Now, in our x and y intercepts, basically, you already have the idea of these terms when you were in grade 8. X-intercept is the intersection of your graph to the x-axis. The x-intercept is also known as the zeros of the function. Now, look at this parabola. As you can see here, this is the x-axis, right? Now, the intersection of the parabola to the x-axis, this is the one, and this is the other one. That is what we call the x-intercepts. Easy, right? Okay. Now, the y-intercept is also basically the intersection of the parabola to the y-axis. This is your y-axis, and this is your intersection of the parabola to the y-axis. That will be your y-intercept. So, how do we name our x-intercept and y-intercept? So, this y-intercept is located at 0, negative 2. While this x-intercept is located at negative 1, 0. And here we have positive 3, 0. Okay? So that is just how you get your intercepts if you have a parabola. Now, if you don't have a graph and you just have to solve for the parabola, we will also gonna talk about that on our next videos. But to give you a hint, the y-intercept in your general form is basically the value of your c. Okay? Or your constant term. That's a hint. While your x-intercept is the value of your x when your y is equal to 0. If you could still remember how to solve for the value of x in the quadratic equation, those values of x, that will be your x-intercepts. Okay? So that is how we determine the x and the y-intercept. Talking about quadratic functions, we will always gonna tap the terms domain and range. The domain represents your x values, while the range represents your y values. Now, in the given parabola, whether it is upward or downward, the domain of the quadratic function is basically x, such that x is equal to the set of real numbers. Now, as you can see in our parabola, it goes upward, it goes downward. Remember that this parabola extends, right? From a very small opening going to a very big opening, it will take up all the values of x, regardless whether it opens upward or it opens downward. As you can see here, these are values of x. As you can see here, these are values of x. Regardless you are here, there is a value of x. Regardless of you are here, there is a value of x. Regardless of you are here, there is a value of x. And this will extend, right? So basically, it will take up all the values of x. So that is the set of real numbers. So that will be your domain. Now, how about the range? The range is the y-intercept. Now, unlike the domain, it is the set of real numbers, the range is different. Why? Because it is the boundary where it turns or where the parabola turned. Okay. As you can see here, our vertex is located at, let's say, so this is in the middle of -2 and -3. So I would say that the value of our y is -2.5, for example. And our x is at 1. Okay, so that is 1, -2.5. That is the location for our vertex. Now, this k, which that is h and k, that k is the boundary of your graph. So, from here, since this opens upward, from here, going upward, that is the boundary of your range. So, how do we write this one? So, that is y, such that y is greater than or equal to -2. Now, for sure, you will be asking, Sir Ash, do we always use the greater than or equal symbol for our range? Basically, it depends. If it opens upward, you will use greater than or equal. That is if the graph opens upward. But if it opens downward, example, we have like this, okay? And this graph, for example, the vertex is located at 1, positive 4. Okay, example, 1, positive 4. So, for this one, our parabola is opening downward. So, your range will be y such that y is less than or equal to positive 4. Why is that so? Because the turning point of this parabola is at 4, but it will never go up, right? So, it's just the maximum is 4, and all of the numbers below is part of y. So, that is less than 4. So, those are 3, 2, 1, 0, and negative numbers. Okay? While if it opens upward, this will be higher. So, greater than. We will use greater than or equal to. While if it goes downward or it opens downward, we will use less than or equal to. That is how you name the domain and the range of a quadratic function. But more about that when we will tackle and go deeper about solving and interpreting quadratic functions. So I hope you have learned the terms that you will encounter in our discussion about quadratic function. And if you do have some confusions about these terms, do not hesitate to put your inquiries in our comment section below. This is still your free access math teacher Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you so much. God bless and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.